Hello and welcome to the 741 channel. Thank you for stopping by. Today we're going to work on replacing my well water pressure tank that you can see here behind me. So a couple things to mention before I get started. First off, I'm just an average homeowner. I'm not a plumber. So this video is just for reference only. There may be better ways to do this, or there may be codes that you need to follow in your area. So please check on that before you attempt to do something like this yourself. Now, one other thing I want to mention, because I'm not a professional plumber and I'm just a homeowner, this is not a strict how-to video, it's more of a how I did it video. You may want to do some of the same things that I've done here in this project, or you may want to do things completely different. It's entirely up to you, and as I said before, the video is more for your reference than anything else. And as I said, this video is just for reference, so any damage that you may incur to your property or yourself is strictly your own liability, and I have no responsibility in the matter. In other words, if you don't know what you're doing, get help or hire a professional. Before I move on with actually replacing the tank, I want to show you guys how I know that it's bad in the first place. So let's head upstairs to my kitchen sink and take a look at my faucet. So hopefully the camera showed that in the kitchen sink, the water pressure was sort of not steady. It was kind of strong for a little while, it would taper off, and then within about 10 to 20 seconds, it would kind of go back strong again. And so now let me demonstrate what is going on here at the water tank when the water is running and that pressure is pulsating. We're down here taking a look at the bottom of the tank, and in particular the pressure gauge and the pressure switch is up here. Now also at this time I've got the kitchen faucet running, so there's a steady draw of water on the system. Now what you may be able to see is happening is that the pressure down here is fluctuating in about a 10 to 20 second cycle. Pressure goes down to the point where the switch cuts it in, turns the pump on out in the well, which then pressurizes the system, and then it draws down within that 10 to 20 second cycle. Now normally, if your system is running correctly, that cycle should be much longer. So this is really the first telltale sign that there's a problem with the pressure tank, and in particular the air bladder that's in the pressure tank. So let me explain that now. So again, I'm not a plumber, so this explanation may be a little bit simplified to those of you in the audience that really know these systems. But for most average homeowners, this should more or less make sense. Now of course we have the water tank here, but this whole thing is not completely filled with water, or at least it's not supposed to be. The top quarter or maybe third of it is actually a rubber air bladder that sits up here on the top and will normally exert pressure on the water below it to kind of maintain an even pressure and keep the pump from cycling on and off as quickly as mine is right now. So what's happened in my system, I suspect, is that my air bladder has developed a hole, or it's come unsealed or something inside the tank, so I no longer have that constant pressure pushing down on my system. So as soon as I turn on a faucet or something like that and draw pressure out of the system, the pump needs to turn on and pump water back into the system to maintain that pressure, because that air bladder just isn't doing its job anymore. So aside from the pulsing water pressure at the faucet and the fact that we can hear the pressure switch kicking on and off in that 10 to 20 second cycle, there's a couple more things we can do to kind of verify that the bladder in this tank is bad. So on the top of my tank you can see there's an air bladder here, and it's very similar to what you'd find on your car's tires and works pretty much the same way. Now the first thing that I'm going to do is I'm going to quickly depress this with my finger to let some air out, and when I push it down, really in theory the only thing that should come out of here is air. If that diaphragm has been breached in some way, then a little bit of water mist will also come out with it. Now you're not going to be able to see this on the camera, but when I do push my finger on there, I can feel the wetness of the water coming through it, which tells me that I do have a breach. So sometimes what can happen is you can check the valve for moisture or water coming out and you won't feel any. You may still have a breached bladder in here, but the water just hasn't reached all the way up to the top. So one definitive way to check is to kind of shake this thing or tap on it to see if you can tell if there's water up at the top part of the tank. If you can hear water sloshing around up there, that means your bladder has been breached and you need to replace your tank. There's no way to repair it. I don't know if you guys will be able to hear this on the camera, but I've already kind of shaken mine a little bit, and I can hear water sloshing around up in here. So that's how I definitively know that this tank is shot and it's time for a new one. So one other thing that can happen with these things, that's an easy thing to fix, doesn't require replacing the tank, is that bladder can just kind of lose some air over time. And you may be able to just put a little bit of air back in it and have everything go back to normal. So before you go ahead and replace your whole tank, what you may want to do is drain the water out of the tank, get all the pressure out of the system, and then put an air pressure gauge on the air valve up here. That's, well, in my case, on the top of my tank. Yours may be somewhere else. But anyway, put an air pressure gauge on there and check it against the manufacturing label to see if you've got the correct amount of pressure in there. If you just have low pressure, you may be able to just add a little bit of air, and that may fix your problem without having to replace the whole tank. So now I'm going to get started with actually replacing the tank. The first thing that I'm going to do is go over to my breaker panel and shut the breaker off that powers my pump and the system. As an added precaution, I'm also going to shut off this switch that's located here next to my water tank, just in case. So the next thing I'm going to do is shut off this valve that I have up here next to this water filter. What that's going to do is that's going to prevent any water that's in the plumbing up in the house from draining back down here and making a big mess. So the next thing that I'm going to do is drain all the water out of the tank. You can see there that I've got a garden hose connected to the drain valve down at the bottom of the tank. And that's just running across my basement floor over to the doors and will drain out into the driveway. So while I wait for the tank to drain, I'm going to pull the cover off of my pressure switch and disconnect the wires that go to it. Now here's a close-up look at what mine looks like. Before you take yours apart, you'll want to note how your wires are connected and make sure you put them back the same way. In addition to the terminals, we'll also need to disconnect a couple of ground wires down here. So with the wires disconnected, now what I'm going to do is unscrew these conduits on either side of the switch so that I can pull the wires out of the way. Okay, so I've got the tank drained off as much as I can, but I don't think a whole lot of water has actually come out of this thing just yet. So anyway, what I'm going to do at this point is I'm going to close off the main shutoff valve to the water system, and then I'm going to disconnect the drain valve down there and remove the hose. We'll have to work with it the way that it is. I'll still be able to pull it out of the house this way. It'll just be a little bit heavier to work with, and then I can drain it the rest of the way when it's outside. Next thing I'm going to do is loosen up these hose clamps on this pipe that goes out to my well. Now I've got a bucket here because I expect there'll be a little bit of water coming out of this. Hopefully not too much. I guess we'll see what happens when I pull it out. Okay, I've got the hose clamps loosened up and out of the way. I'm going to use this set of slip joint pliers to kind of crack this hose off of the inlet nipple here. Okay, so I've run into my first bit of trouble. You may be able to see here there's a little bit of water on the floor. I did get the seal on this cracked and I was able to start moving it up. You can see it's kind of chewed up. I was using my pipe wrench on there and my slip joint pliers to kind of try and grab it and pull it up, but no matter what I did, I couldn't get it to release from the nipple. So I think what I'm going to have to do is cut the pipe down here as short as I can, and then I'll either get a longer nipple or find a way to splice this pipe back together later. The other thing that's happened is I've kind of wrenched on it so hard I cracked the pipe here, so it's going to need to be cut and replaced anyway, so might as well do it now and make the removal process a little easier. So I'm going to cut this as close to this nipple as I can, as there is no slack in this pipe at all. So I want to leave myself as much length as I can to work with here. So now I need to disconnect the plumbing from this side of the tank. Now, as you may be able to tell, there is no union or easy way to break this connection with a wrench. I either need to try and unsolder it or cut the pipe and couple it later. Now, I have made an attempt to try and unsolder it at this point, but there is water and stuff in the pipe, so I can't get enough heat in there to kind of get this connection to unsolder. So what I think I'm going to do is I'm going to cut this short piece of pipe, and then I'll replace it later when we put everything back together. Okay, so I'm just going to use this pipe cutting tool to make the cut. I'm going to also cut this roughly in the middle so that if I want to just use a standard coupler on here to kind of fix this connection, I can do it that way. Now that I've got both sides freed up, this tank should be free to come out of here and we can get the new one in place. Okay, so here's a look at the tank that I chose to replace my old one. This, as you can see, is a WaterWorker HT-32B 32-gallon tank. Has very similar specs to the one that's already in my house. Now, I ended up picking this up at Home Depot. Now, if I had more time to shop around for a tank, I might have gone to a local plumbing supply store and gotten one from there that may arguably be a little bit better quality than this. But at the time that this happened, I had some personal things going on and I had a very short time frame that I had to work with in order to get this replaced. So it was easy to just stop at Home Depot on my way home from work and pick this up. So here's a look at the new tank out of the box. You can see it's a lot like the old one. I think it's a little bit narrower and maybe a little bit taller, but in my case the exact size doesn't really matter. I've got plenty of room to work with. One thing I do like about the tank is that it says that it's made in the USA. Now, you've really got to kind of take that with a grain of salt. There may be components in here that are manufactured overseas, but at least the final assembly and stuff was done here. At least enough of it so that they could put this on the tank. So here's a quick look at the underside of the tank. Now, this one comes with sort of an integral metal standoff that it sits on. I think my original one is plastic, or at least plastic coated. So if you've got this thing in a damp area, where water might get up in here, this thing may rust on you over time, so that may be a little bit of a concern. But for me, it's not. My basement is pretty dry, and I've got it elevated up a little bit, as you saw in the videos. Now, the main connection here appears to be a 1-inch connection, just like my original tank, so that should be good. The only thing we'll need to do is remove this protective cover out of here before I start hooking up plumbing. As you may have been able to tell, I couldn't get all of the water drained out of it, so it's still a little bit heavy, but at least I got some of the water out, so I was able to kind of get it out of there without breaking my back. Let's wheel it outside and get the new tank in. So you can see I've got the old tank out here on its back, and what I'm going to do is I'm going to try and take this shutoff valve and this arrangement off of here and replace it with some new stuff before I try and remove this whole T from the old tank. Okay, so when I first inspected this, I thought that the shutoff valve was corroded on the bottom, but you can see there is a little bit of corrosion there, but that's just surface corrosion. That wouldn't have bothered anything. But since I bought a new one, I'll change it anyway. Next up, before I put the new shutoff valve on, I think I'm going to try and pull the old T off and swap it over to the new tank. So I've run into a problem that I didn't expect. I don't know if you guys can see inside the end of this pipe or not here, but there is a whole bunch of sediment blockage in there. There's a whole bunch in the tank too. Now, of course, as you saw, my water system was functioning even with the sediment in there, but the sediment is probably what led to premature failure of this tank. So my original plan was to reuse as much of these fittings and plumbing as I could, but because this thing is all packed with sediment now probably, I think I'm going to go to Home Depot and get some new stuff. Okay, so as you can see, what I've done here to just get the rest of the water out of this tank was I drilled a hole at the bottom and I'm letting it drain out. That way here, as I have to manhandle this thing around the yard and ultimately out to the curb, it'll be a little bit easier to do. Okay, so I finally made it back from Home Depot. So what I've got over here on this side is a brand new mocked up system with all the fittings. Now this is just dry fit in here. I don't have any Teflon tape or pipe dope or anything on there. I just kind of loosely put everything together to make sure it was the right size and that I had everything that I needed to put onto the tank. Now over here, of course, is the old system. Now of course, you may notice I haven't put the pressure switch on here yet. I may not reuse that pressure switch. I may use the old one, just because I think the old one may actually be better quality than that Chinese junk one there from Home Depot. The other thing I may reuse is this pressure gauge if it's not too clogged up with sediment. This one is probably better quality than the Home Depot one, but I think I'm going to replace everything else, including this check valve. Even though this one is probably a better unit than this Chinese one, I think it's full of sediment and could have some issues, so I will replace that, even though I'd rather have a better quality one. Everything over here seems to match size-wise to what's over here, so I ought to be able to just bolt all this stuff to the tank, and I should be good to go. It should fit my system where the old stuff was. So the one difference between the old setup and the new setup is that I put an extra coupler in here to lengthen this pipe so that it will reach the black inlet pipe from the well. If you remember, I ended up having to cut that over here because I just couldn't get it off this nipple. And there is no slack on that black pipe, so I needed to lengthen it to make sure that it would fit in the old spot. So what I'm going to do now is disassemble all of this stuff and then put just the T onto the bottom of the tank and then get the tank positioned over there where it belongs. As you can see, I've got the tank tipped up a little bit there, and I'm ready to put the T on. First thing I'm going to do is put some of this pipe dope on the threads of the T. Now, I've never used this stuff before when I've done plumbing. I've always used the older Teflon tape method, so I'm going to give this a try. Hopefully it'll work for me. Now that I have the end of the pipe doped up, I'm just going to remove this plastic cap that's in here, and we'll thread this in place. Okay, so that's in and tightened up. I'm going to put the assembly back on those bricks where the original tank was sitting. So the next thing to do is check the pressure in the air bladder on the new tank. Now, it should be set from the factory at the right setting, which for my application is 28 psi. But I'm going to double check it anyway with an air pressure gauge just to make sure everything is good. Okay, and we're reading right around 28, 29 psi, so that should be good enough. This isn't the most accurate gauge in the world, so I think we're good to go. Now that I've got the tank in place, I'm going to work on building out all the fittings here. I'm going to start with the inlet side, get that all built up and kind of in place, and then I'll go to the outlet side. I'm getting ready to put the check valve in place, and I just wanted to show that there is an arrow on these things that indicates the direction of flow. So because this is an inlet check valve, we're going to make sure that this side, or the back of the arrow, is pointing towards the well inlet, and that the front of the arrow is pointing toward the tank. A little bit of a progress update here. You can see that I've got the inlet side all plumbed up and ready to go. I started taking a look at the old pressure switch to see if I could reuse it. I took it off the old assembly and kind of looked in there, and I don't know if you guys can see in this lighting, but it's pretty full of junk, just like everything else. So I think I'm just going to use the new switch I got at Home Depot at this point. So here's a quick look at the new switch. It comes with some instructions, and we'll get this wired up after. Okay, a little bit of a progress update here. You can see I've got the new pressure switch, the pressure gauge, and the drain valve all installed. And what I'm about to put on now is the pressure relief valve. So the purpose of this is for safety. If the system for some reason gets too pressurized, this thing will open up and start draining out of here rather than, you know, pressure the tank up so much that it explodes or something like that. So we'll put this on next. And you can see this has direction of flow arrows as well, although you really can't put this thing on backwards, but you do want to kind of have this end of it oriented down. So another progress update here. You can see that I've got everything all fitted over here as far as the threaded fittings go. And now it's time to get that last threaded coupler in here and get a piece of pipe soldered in place. So that's what I'm going to do next. So while I wait for my solder joint to cool there, what I'm going to do is pull these pieces off of the old pressure switch so I can transfer them to the new pressure switch. Over at the new pressure switch, you can see I've got the pump side conduit adapter already mounted over here. And over here, I'm just going to pull this rubber plug out and get ready to mount the switch side conduit holder in place. So next up, I'll start fishing the wires through the conduit mounts here, and I'll get the ground wires connected to these screws down here on the base of the switch first, and then I'll connect the main wires up here to the switch. Okay, so I've got the ground wires connected, and I've got the knobby tubing locked into the conduit holder here. Okay, so now what I'll do is reconnect these wires. I looked back at my old setup, and it looks like we should do the two black wires on the left here, and then the red wire, and then the white wire. So I've got all the wires in here neatly routed and secured down, and we're ready to put the cover back on and move on with finishing up the plumbing over there. So I think my solder joint looks reasonable. I wouldn't cut it as a professional plumber, but this shouldn't leak. So what I'll do now is just do a quick fit in here and then cut this pipe to length. Now, one thing to note, this piece of pipe is not a new piece that I got from Home Depot tonight. This is an old piece that I had in my plumbing box that I'm reusing. Okay, so I've got that cranked in fairly far, and we'll just take a test measurement here. Now, I've got a little bit of wiggle room on this pipe, so we don't have to be exact, but no need to put any undue stress on this, so we'll get as close as we can with it. Okay, and while I got the pipe free, I'll just clean this end up and get it ready for soldering, since it's just a little easier with it out here rather than mount it over there. Okay, so next up what I'll do is flux this up and solder this joint. Now this one will be a little bit tricky just because there's some old solder in there, and also there may be a little bit of residual water in this pipe that's going to make it a little tricky to solder, but I think we'll be able to get it. Okay, so I've got that joint all soldered up. Probably not going to win any plumbing or soldering awards, but it ought to do the job. While that cools, we'll reconnect the well inlet tube. Okay, so now this is just a matter of muscling this onto this barb here. So I finally got everything all together. I think we're ready to throw the breaker, put some power to the pump, and do a leak test at this point. Now, to those of you who are paying attention, you may notice that over here, this length of pipe here got a little bit longer. And that's because when I first originally dry fit this, I had a 2-inch pipe in here, and it seemed like it was going to work. It seemed like that would be the correct length for everything to fit. But as it turns out, this was just a little bit too short with that 2-inch adapter in there. So when I was at Home Depot, I did pick up a 3-inch adapter just in case, knowing that I may run into this issue. So I was able to swap the 3-inch adapter in without taking everything apart. I was able to just break this off and put this in place, and I think we've got it all tightened up here and ready to go. So I'm almost ready to turn the switch on for the pump that's right there above my head. But before I do that, I want to mention that this new pressure switch has a low cutoff feature. So when you first energize the system and get it up to pressure, this switch that's on the side of the pressure switch here needs to kind of be manually operated until you get above the lowest cut-in pressure, which in my case is 30 psi. Once the system gets up to 30 psi, then this just kind of works automatically on its own. But until it does, you've got to kind of play with this lever and make sure the switch turns on and the pump runs and that sort of a thing to get up to pressure. So the reason for that is that this switch contains a built-in sort of safety mechanism, so that if you had a major leak and you lost complete pressure, this thing would shut off and wouldn't allow the pump to keep running and, you know, putting water in the system and potentially in your house. So that is a nice feature, but just got to keep that in mind when you're starting from scratch. So I've got the system sort of up to pressure here, but as you may be able to see, I've got some leaks here. So it looks like I got to do some more tightening up. Maybe that pipe dope isn't all it's cracked up to be. Maybe I should have stuck with the Teflon tape. So my initial leaks were coming from the pressure gauge and where the pressure switch mounts in. I just didn't have those tight enough. So I was able to just tighten them up where they are in place without too much trouble. I did have to disconnect the wires from the pressure switch to kind of tighten that down some more, but that took care of those leaks over there. Luckily I didn't have any leaks in the solder joints. I was more worried about those than anything else, but they seemed to be okay. No issues on that side. Over here I had some problems with the threads on these fittings here, but I was able to just tighten these up a little more with the pipe wrenches, and that took care of those. With the exception of up here. After I got all that taken care of, I still had a drip up here. Now I originally thought that my problem was where the black pipe goes over the barbs of the brass nipple. That would be a logical place for it to leak. So I kind of played with these hose clamps and got them as tight as I could, and it was still leaking. So after looking at it a little closer, I realized that the leak was coming from the threads where the brass nipple goes into the coupler below it. So what I ended up having to do with that is I had to kind of back it off as much as I could to get as many threads exposed as possible without actually disconnecting it. And then I wrapped it up with some traditional Teflon tape here instead of that pipe dope, and then tightened it back up to a reasonable amount, and it was okay. So I think the moral of the story here is either my inexperience with the pipe dope or maybe the Teflon tape is just better. It certainly isn't as messy as the pipe dope. I've gotten that all over the place throughout this whole job. So I think in the future I'm going to stick with the Teflon tape, even though it takes a little longer to apply. Now that I've got all the leaks and drips taken care of, I'm going to open up all the valves and get some water running up in the house and see how everything works. So I think that's pretty much going to wrap things up for this project. We've been running the water in the house for about an hour now, doing dishes, things like that. Pressure seems nice and even like it should be, no more pulsing, and the pump seems to be running at its normal rate. So I think we're good to go here. So now I am going to have to address that sediment issue at some point here. Now the old system had been in place and working fine for about 8 years, and that's not too bad all things considered, but there's other issues with having sediment in the water. Now I do have an upstream sediment filter that kind of takes care of sediment getting into the house, but that's not going to prevent it from getting in the tanks. I need to get something at least between the tank and the well to keep the sediment out of the tank and that part of the system. But for now we've got running water in the house again, so I think we can kind of get back to normal for a couple of weeks while I figure out what to do next. Now one other thing I want to mention, because I'm not a professional plumber and I'm just a homeowner, this is not a strict how-to video, it's more of a how I did it video. You may want to do some of the same things that I've done here in this project, or you may want to do things completely different. It's entirely up to you, and as I said before, the video is more for your reference than anything else. If you enjoyed this video or found it helpful, please give it a thumbs up. And if you'd like to leave a comment or subscribe, feel free to do that as well. Thanks for watching.